In our last lesson, we took a quick look at central tendency for data sets. Today, we're going to just kind of extend that a little bit further and look at central tendency for grouped data. We're going to start off with specifically weighted means, which is actually dealing with fairly small data sets as well usually, but it's going to get into the idea of how these things work. So one of the most common places that you would use a weighted mean would be to calculate your mark in a class. So for example, we're putting down here that your final, now this isn't realistic to this course and probably not realistic to any of your other courses, perhaps a university course. But your final mark is 55% of your term work, 20% project, and 25% final exam. If you get 83% of your term, or sorry, if you get 83% on your term work, 57% on your project, and 71% on your final exam, what will your overall mark be? Well, here's what we're going to do. I'm not going to write this out symbolically with symbols like I normally would. We're just going to write down the mean equals. Okay, so I guess that's a symbol. What we want to do is say what each mark is and then multiply it by how much its weighting is, how much it's worth. Now, this one, I'm going to be kind of careful. If I was doing the weighting of, say, for instance, 3 distances, they would be measured in meters, or 3 times, they would be measured in seconds. In this case, we have percent used in kind of 2 different ways. I mean, technically it's the same way, but for this question, when we talk about the exam being worth 25% of our mark, we really do mean 25 hundredths. However, when we talk about the exam mark itself being 71%, we're going to think of that percent as being the unit of the question. That's the thing that we're measuring, is our mark. So I'm not going to actually put the percentage sign on that, and hopefully that'll make some sense. So let's start off with, we got 83% on our term work. So I'm going to take 83, and again, I'm not going to put the percent sign down because that's the unit of measurement for my mark. And I'm going to say that's worth 55%. So I'm going to multiply it by 55%. Plus, the next one, we have a project that we got 57% on, and it's worth 20% of our mark. Plus, we had 71% on our exam, and it's worth 25% of our mark. So we've added up each of the values we've got times its relative frequency. So 55% of our things are term work, 20% of our stuff is project, 25% is final exam. And then we always divide by the total representation, which in this case is going to be 55% plus 20% plus 25%, which is 100%. Now the beauty is we can actually just ignore the bottom of that fraction from here on in because percent means out of 100. So the bottom is just 100 over 100, which is 1. Okay, on the top, when I punch this into my calculator, and I'm going to actually do this in 2 steps. So I want to remember that 55% really means 0.55, 55 out of 100. So we have 83 times 0.55, which is 46.55. 57 times 0.2, which is 11.4. And 71 times 0.25, which is 17.75. And just a reminder, don't need to worry about the bottom because it's just 1. And so finally, we just add those numbers together, and we get 75.7. Therefore, our final mark is 75.7%. And by the way, in most cases, I'm not too big on making sure we have therefore statements as long as you have logical conclusions in your answers. Now, I should point out that weighted means don't always have to be broken down by percent. So for instance, while I do usually do something like this for my courses overall and say term work will be worth this percent and exam will be worth this percent and so on, for my term works themselves, those I don't actually break down and say unit 1 is going to be worth 15%, unit 2 is going to be worth 18%, and so on. What I do is and I know some other teachers do it, at least math teachers who understand how math works do it this way, um, is I'm going to weight my different units based on how many days in class we spend on them. So if I have 12 days of lessons, I'm going to weight it as 12. And if I have 8 days of lessons, I'm going to weight it as 8, and so on. And the beauty of this is that they don't have to add up to anything. Whereas before they had to add up to like 100%, so that it made sense. I couldn't say your mark is going to be 50% this and 70% that. That doesn't make any sense whatsoever. But here I'm just giving weighting factors. And if there's only a total of 20 on the bottom, that's okay. That's 20, still something out of 20. Um, and I also want to point out you don't have to convert each of these to a percentage before you do this calculation. It's actually much easier to not do that. So if I wanted to figure out the term mark here, what I would do is say, and again, the percents in this question here for the marks are units, so I'm not going to include the units in my calculation. I don't want to convert to decimals. I want my answer to be in percent. I'm just going to say, okay, I've got 80%. And I said I wasn't going to write it down, and then I started to write it down. No writing it down. There we go. Okay, so 80%, and I'm going to weight it at 12. So 80 times 12. And actually, just to be a little bit more consistent with how I did the other ones, I'm going to use brackets instead of multiplication signs, just because they're so easy to mistake for x's. So 80 times 12 plus 75. Why can't I write today? That's a lie. I can't write any day. 75 times 8. 70 times 10. 90 times 11. And 80 times 9. Okay. Now, on the bottom, I need the total of all the weight factors, which is 12 plus 8 plus 10 plus 11 plus 9. So now I've got to just use my calculator and figure out the different pieces here. 80 times 12 is 960. 75 times 8 is 600. 70 times 10 is 700. 90 times 11 is 990. And 80 times 9 is 720. Okay, I guess I didn't need a calculator. On the bottom, I've got 12, 20, 30, 41, 50. Now this time it works out to be rather nice at 50. It's a nice number to work with, but it doesn't have to work out nicely. It can be any number. It could be 43. The neat thing is you can even give these weighting factors like of decimals. I could just say, well, I spent like 12 and a half days on the first unit. It won't change anything. I mean, the numbers will change, but it doesn't change the method in the slightest. Okay, now I'm actually going to use my calculator because I don't feel like keeping track of that many digits in my head at once. 960 plus 600 plus 700 plus 990 plus 720 is 3,970 divided by 50. And when we do the division, I get out that the mean, the weighted average, is 79.4. And I'm going to write percent there. I can write it my last step the same way that if I was doing a distance, I would write meters or kilometers in my last step. That's okay. I'm just including the units. So the last thing that we should probably do before we continue on to the next question is just to look at that and say, does that make sense? Now, our units are all approximately equally weighted. They're all there kind of in the middle. Like the difference between 12 and 8 is pretty big, but not huge. And our marks look like they're consistently between 70s and 90s. So yeah, 79.4 makes complete sense. If you ever are working on something like this in evaluation, I'm sometimes pretty forgiving about making little mechanical errors. So maybe when you were typing in this number right here, instead of typing in 990, you typed in 900. Okay, it happens, no big deal. Or maybe when you typed in the first number, instead of 960, you typed in 690. It happens. The question is, how much difference does it make? So I'm not saying that, some calculator errors are more important than others. Wrong is wrong. But does your final answer make sense? So in this case, if you typed in 900 instead of 990, I think you'd get an average out of 77.5 or something like that, which still is kind of reasonable given the situation. It looks like it could probably be in there. If, however, you typed in that first number as 690, I think that would take you off by about, I think you get a number about 73. Well, when I look at this data set, there's only one number below 73 and it's not much above it or below it. And then everything else is above it. Some of them significantly above that. That seems a little low to me. And if you ever have a number that is lower than the minimum or higher than the maximum, you're definitely going to lose an extra mark there just because your number is ridiculous. Um, so just as an example, I had a student several years ago who, not the best student, nice kid, not the best student. Um, he had failed every single evaluation that he'd done. Now this was like midterm, so there was still time. I don't think there was for him, but there was time theoretically. Failed every single evaluation and asked me what his midterm mark was, and I told him it was, a fairly low mark. And he said, "Oh, I thought I was passing." And I said, "Well, how many evaluations have you passed?" And he said, "Well, none of them." I said, "So you've never passed anything, but you thought your average was a pass?" And he goes, "Well, yeah." So, okay, see that shows a serious misunderstanding of how math works. You can't have like a maximum mark of 43 on an assignment and then expect your average to be 60. It just doesn't work that way. Um, I also had a student once that was really cocky going into the final exam, didn't study or anything. And I said, "Well, I hope you studied because you really need to get a good mark on this exam to pass." And he goes, "No, I don't." I said, "Well, you've only got a 40 going into the exam." And he goes, "Yeah, exactly. I only need 10% on the exam to pass." Like, no, that's not how it works. He doesn't, the marks don't add to like 50. They have to average to 50. Big difference. So anyway, there's my rant for the day. Okay. If we want to find means from frequency tables. So here we have a frequency table. Now, a frequency table is really no different than giving a big list of numbers, except instead of writing out the same numbers over and over again, I can just tell you how many I have of them. So this represents some figures in my action figure collection. And I'll be honest with you, this is really just a small sample of my action figure collection. But anyway, here's some figures and the values of them. So I have 21 figures worth $10 each. I have 13 figures worth $20 each, 5 figures worth $40 each, and 1 figure worth $80. So could I figure out what the mean of this is? Did I say median before? I don't even know what I'm saying these days. The mean of this, what I could do is say x bar, which is the mean, is equal to 10 plus 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 10 plus... Yeah, I'm even getting dizzy saying it. I could write out the 10 plus 10 plus 10 21 times, plus 20 plus 20 plus 20 plus 20 plus 40 plus 40 plus all that stuff, and then divide by all of the total number of figures, or I can just multiply it and treat it like it's a weighted mean. So I can say I have 10 figures at $21 each. Sorry, 21 figures at $10 each. I have 13 $20 figures. I have 5 $40 figures. And by the way, the order of the multiplications don't matter. It doesn't matter whether I put the frequency or the value first. And I have 1 figure at $80. Now on the bottom, I have to add up the total frequencies, everything. And make sure it's the frequencies you're adding and not the figure values you're adding on the bottom. I have a total of 21 plus 13 plus 5 plus 1 figures. Okay, so then we just do this. And again, you can plug it all in your calculator at once. I usually just do them out a little bit individually in case my calculator has a little error in it. You know what, before we do that, let's just look at that data set and see what we think the average is going to be or the mean is going to be roughly. Now, I got a lot of low figures. I mean, that $180 figure, but there's only one of them. I'm going to guess that my amount is probably in the high teens, maybe the low 20s. So maybe like 17, 18, 19, 20, 21, $22, something like that. But just by approximating it in my head, even though that's a pretty wide range, I still know whether to be suspicious of my answer or not. So I'm expecting something, let's say around 20 bucks. Okay, so when I do this, I get 210 plus 260 plus 200 plus 80. And on the bottom, 21, 34, 39, 40. Okay, trusty calculator. 210 plus 260 plus 200 plus 80 is 750 divided by 40. And when I do that, I get 1875. Okay, so a little under $20. It's in the ballpark of what I was suspecting, so I'm not suspicious that my answer is wrong. And if I did make a mechanical error on a test on something like that and got that answer out, and the correct answer was $19 or $21, something like that, I wouldn't be too worried about it. What would worry me is if I said my average figure was worth $145, which is completely ridiculous, or my average figure is worth $8.20. There's just no way. It can never be bigger than the max or smaller than the min, and usually you can do a lot better than that by just kind of simple logic. Okay, means of group data in intervals. So this is something that is very similar to what we just did above. The difference is I'm not saying I have 7 things. Now in this case, it's the height of, I didn't say what the height was for. Let's say it's people in my class. Yeah, it looks reasonable. Okay, so we've got heights of different people here, and we know that there are 7 people between 150 and 160 centimeters. Actually, I'm just going to go back 1 second. The reason I could put this in a regular frequency table is because the values of the figures, the $10, 20, 40, and 80, are discrete numbers. They're all numbers with definitive jumps. Now, you could argue a little bit that there's, decimals and stuff in there, but either way, I can say that this figure is worth $10, not 10.0285 or something like that. Here with heights are definitely a continuous value, so we're going to have to put them in ranges. I can't say I have 7 people that are 150 centimeters tall because there's no one person in the world who's 150 centimeters tall to an infinite number of decimal places. They might round to 150 when I go to the closest centimeter, but no one's 150. So I can say, however, that there are 7 people between 150 and 160, 18 people between 160 and 170, and so on. So when I'm doing this, when I have a table like this, I've actually lost information from my original data set. And what I mean by that is knowing there are 7 people between 150 and 160 doesn't tell me anyone's weight. For all I know, all 7 of them could be 151, or all 7 of them could be 159, or whatever. And any of them can be anywhere in that range. And because of this, I can't find out a true mean for the whole data set. I can only find out an approximate mean. And what I'm going to do for each interval, because I don't know where people are, I just know they're between 150 and 160, is I'm going to make the assumption that they are at the halfway point. So my mean is going to be 7 people. And again, I know they're between 150 and 160, so I'm just going to assume they're at 155. And then there are 18 people. I'll assume they're at 165. And 11 people at 175. And 6 people at 185. And I have a total of 7 plus 18 plus 11 plus 6 people. So now I can just calculate all of these little pieces, and we have 1085, 2970, 1925, and I'm hoping I get these correct. At some point, I'm going to do a goof on one of these, and I'm going to fix it eventually, but I'm probably not going to reshoot the video. That's okay. If you think I've made a mistake, let me know, and I will look into it. So one disadvantage of not doing it live in class is that I don't have students yelling at me and saying, Mr. Ray, that's supposed to be a 7 and not a 3. Okay, so 7 plus 18 plus 11 plus 6 is 42. Add up all those top numbers. 1085 plus 2970 plus 1925 plus 1110. 7090 divided by 42. And when I finally do that, I think I get out 168.8. And again, in my final line, I don't feel bad about putting units on, even though I don't put them in anywhere else. So again, this is an approximate because we don't have individual data points, so I can't say the true median is 168.8. All I can say is that given the information I have, my best guess is that the average is 168.8, or about 169 centimeters. And if I look at my data set, that's at the upper end of my second what's the word I'm looking for, interval of data, which makes sense because there's actually more data above it than there is below it. So it probably should be at the high end of that. Okay. Medians. Medians are easy. You list all the numbers in order. You tell me which one's in the middle. Now this one's a little bit different when we do it with frequency tables like this, or with interval tables, I should say. What we really need to do is look at it and say, how many total, in this case, classes are there? Sorry, I was looking at that backwards. I said the right thing, but my brain was going backwards. So we want to find the median number of kids in each class. So what this is saying is that if I took a look at all these, let's say, classes at my school, I could say that there are 3 classes that have exactly 13 kids in them, and 10 classes that have 14 kids, and 5 having 15, and so on. So what's the average number, or the median number of kids per class? Well, in this case, the kids are the measurement, and the classes is the frequency, how often that measurement occurs. So what I want to do is find out the total number of classes. And I could write out 3 plus 10 plus 5 plus 3 plus 2 plus 1 plus 1, but I'm going to just kind of do that in my head and say that's 18, 21, 22, 23, 24, 25. So if I have 25 data points, which one is going to be the middle one? Now, this is where people usually are a little off. I mentioned this before in the last lesson. When we've got 25 data points, half of 25 is 12 and a half. It's actually the 13th data point we want. 13th point. And the reason for that is because we're not going halfway between 0 and 25. We're going halfway between 1 and 25. So it's the 13th data point. And if you think about it, with 25 data points, the 13th will be the middle. There'll be 12 to the left of it, 12 to the right of it. So now there's really, I just have to find out what is the 13th number in this list. This is where you kind of have to look at it and think about it a little wee bit, but it's not that bad. 13 will be the first 3 numbers. The next 10 will be 14s. That means that the 13th number, the first 3 are 13s, the next 10, so the 4th through 13th are all 14. That means that 14 is going to be our median. So we're just looking at this table, and I know when I ask this on a test, a lot of people will say, well, the middle number between 13 and 19 is 16. That's the middle age, but it's not the middle, or sorry, not the middle age, the middle number of kids, but it's not the middle class. The middle class is a class of 14. And now that I look at it, I really want to teach in this school because I would love a class of 14. But either way, once we found out that the middle class has 14 kids in it, we can say the median equals 14. Now, if the data is like it was before, when we just did the mean for data in intervals, we can't again say what the value of the middle person is. We can only say what category they're in. So for us, what we're just going to say is, in this case, the total frequency. We have 7 plus 18 is 25, plus 11 is 36, plus 6 is 42. So we have to say, okay, if there's 42 data points, there's no central one. But if I went right down the middle, there'd be 21 in the first half and 21 in the second half. So I want the middle is the 21st and 22nd numbers. Okay, so the 21st and the 22nd numbers, and then I just go halfway between them. Well, the 21st number, well, that's the first 7 are going to be there. This is the next 18. Well, we've already counted now for 25 of the numbers. And that means that our 21st and 22nd numbers are both going to be in this interval. And so I can say that the median interval, is 140 to 160. Now, I'm gonna point out, and this is true in a few places in this course. I'm kind of giving you the introductory version. There are actually more advanced techniques that you can learn if you go on to college or university statistics. And there is a way to find out a median number here. Of course, it's going to be approximate like our mean was. And the gist behind it, and I'm just going to give you the gist, is if this one here, we said the first 7 numbers are there, and then the 8th number would start in that region, and the last one in that category would be the 25th. So I think you can see that the 21st and the 22nd numbers are going to be closer to the right. And there's actually a technique you can do to come up with a number, and it's basically going to be a number between 140 and 160 that's a little closer to the 160, but you can get a definitive value. For us, we're going to bypass that because it's a complex calculation. I shouldn't say that. It's not that bad, but there are several variables in it, and they're all kind of confusing to understand what they represent. And so we're not going to worry about that, and we're just going to say what's the median interval for interval data. And then finally, I'm not even going to really spend any time on this. I'm going to let you work on some questions, is the modal interval. And it's literally just which interval has the most data points in it. So for this one here, the modal interval would be the 140 to 160 because it has 18 of the data points. So modal intervals are just dirt easy to do. No modal values, and we'll never have a modal value for anything that's continuous data ever. There's no such thing as which continuous values show up the most often because there is no possibility of any number showing up more than once. There's no possibility of any number being exact in the first place. So that's it. Mean, median, and mode, or central tendency for grouped data. And we'll see you next time where we took a look at something just as important to describe a data set as central tendency, and that would be something called its spread.